Hariom children, let us resume after a short break. Now we are going to the next topic, that is subunit of wave optics, that is interference. Interference, as the name suggests, it is interfering. So here we study this under wave optics. So it must be interfering of two light waves or interfering of light waves. Now, you must have already studied that when a stone is dropped in a pond, you observe ripples. Ripples are nothing but alternate crest and trough in the form of concentric circles. And we say that the distribution of energy is uniform. Now, when you take two stones and simultaneously drop them in the pond, you get ripples due to both the stones. Now, there is a chance that these two ripples superimpose or interfere with each other. Ripples are nothing but alternate crest and trough, I said. So, when the crest of this ripple interferes with the crest of this ripple, what happens is that the displacement will be maximum. When the crest of this superimposes with the trough of this ripple, what happens? The displacement will be minimum, because crest is the portion of the wave which is above the normal position of rest, and trough is the portion of the wave which is below the normal position of rest. So when the crest and the trough superimpose each other, you get the displacement to be minimum or zero depending upon the displacements. Now you get a pattern where the distribution of energy is not uniform. That is, at some points you have maximum displacement, at some points you have minimum displacement, which means that the distribution of energy is not uniform. This non-uniform distribution of energy or redistribution of energy when two waves superimpose with each other is called as interference. What is interference? It is the redistribution of energy or non-uniform distribution of energy when two waves superimpose with each other. That is why we say that interference is based on the principle of superposition. Now, to study what is principle of superposition, principle of superposition is shown over here. That is, you have two waves. This is one wave and this is another wave. These two waves are going in a very synchronized manner. That is, when these two waves superimpose each other, what happens here? The crest of this superimposes with the crest of this. See, all the two waves are going in a very synchronized manner. Crest of this with the crest of this. Crest of this, crest of this. Crest of this, crest of this. As a result, what happens? The displacement will be equal to the sum of the individual displacement. Here actually this represents the amplitude of the wave. Amplitude is nothing but maximum displacement. So what happens when two waves superimpose each other? When the crest of one wave superimposes with the crest of the other wave, the displacement is maximum and you say constructive interference has taken place. At the same time, when the crest of this wave superimposes with the trough of this wave, what happens? The resultant displacement will be the sum of the individual displacement. Since this is on the negative side, it is y1 plus minus y2. Therefore, the resultant displacement is 0, provided y1 and y2 are of the same displacement. So, you get the resultant displacement to be 0. And you say destructive interference has taken place. Now, this is what we are going to study in light. in the case of light, when two light waves superimpose each other, if the crest of one wave superimposes with the crest of the other wave, the resultant displacement and hence the amplitude will be maximum. As a result, the intensity, which is directly proportional to the square of the amplitude, is maximum. So when you say intensity is maximum, you get a pattern where at some points the intensity is maximum. When is the intensity maximum? When the crest and the crest superimpose. So when the crest and the trough superimpose, we get the intensity to be minimum. Just imagine this miracle. You have two light waves superimposing and you get a pattern where at some points you have brightness and at some points you have darkness. So you say that the distribution of energy is not uniform. This non-uniform distribution of energy, when light waves or when two light waves superimpose each other, is called interference. Now, in the case of light, we need two light waves. But you can see that two independent light sources will not give rise to an interference pattern. When you have two bulbs and light from the two bulbs are superimposing, you don't get a pattern. You get some brightness of greater intensity on the screen. You don't get a pattern. Now, why is that you don't get a pattern? For this, we need two light sources which are coherent. And this is what is our requirement. That is coherent sources. Coherent sources we need. Next, we will see what are coherent sources.